Hi there. Since you don't have a graphing calculator, you can try using the Desmos graphing calculator, which is shown right here at desmos.com/calculator. Let's see, what you'll do first is highlight and, select and copy. So you can do the right, after you select, you can do the right click copy, but then when you go to your graphing calculator and just left click in box 1 here, you'll actually do a Control V to paste the table of values into the box here. Now you'll notice that they have that the X1 column has these values right here. You don't actually need all of that information though, and it won't graph that information. So what you'll want to do is get rid of the unimportant information. So in the X column, you'll definitely want to get rid of all of that. So all you want is this part right here. Now you're more than welcome to enter the data values by hand as well. All you have to do is go up here to this plus sign and select table, and then you enter the data values by hand. Now that you have your table of data values, click on this magnifying glass with the plus in it, and it will automatically fit the screen to your data, which is really handy. Okay, so the first item on your list here says use your graphing calculator's linear regression option. Well, for Desmos, that means going to box 2 and typing Y1 and then the little squiggly that's usually in the top left corner of your keyboard. It's called a tilde or something like that. I call it a squiggly for just because that's descriptive. But anyway, for linear regression, you'll type mx1 so that it uses the subscript 1 and then plus b. Notice that it automatically draws the line and it gives you your statistics, your R value and your R squared value, as well as your parameters M and B so that you can write your equation. And then you can notice this gray dot here. You can use that gray dot to answer the questions that are on that are in the problem. So it says, use the function round to the nearest 10th of a million. Does this function value overestimate or underestimate the US population in 2010 given by the table? Well, in 2010, the actual population was 308.7 million. If we go to our graphing calculator and go along the line to, to value 10 here, right here, there it is, right there. I don't know why. Oh, never mind. Don't click and drag, but notice that the black line is under the green dot being the actual value and the line being your linear regression. So it underestimates. Then let's see, by how much? Well, that's where you want to make sure that you can click on the line here and notice that there's a 10 comma and there's 278 point, and the information, your directions say to round to the nearest 10th. So it would be 278.6. So you would actually subtract, of course, 278.6 from the actual data value of 281.4 to get that difference. And then let's see, according to the linear regression model, when will the US population be 400 million? Well, that's where we want to go back to our line here. And since our y-axis is not going up to 400, we're going to shift it down a bit. And we need to shift it over to where our line, our linear regression model line, is actually crossing this 400 line. So right here it's going to be a little difficult here, but we can get really, really close. Really, really close. Yeah, do your best to get a y value of 400, but at least it looks like it's going to be right about 55 years. And since 0 represents 1990, you would add 55, or 55 and a half actually, to 1990 so that you could get the actual, oops, I accidentally right-clicked there. You can get the actual and I completely lost my thought. Sorry about that. The year. So you can actually get the year. So that's really going to be important there. So yeah, subtract or add 55.5 to 1990. All right. I believe that's all of the questions for option B. Then you go back into Desmos and you can either keep this line, or what I would really recommend is turning off the line by clicking this symbol here and going to box 3. So the next let me think. The next regression model it wanted was quadratic. So you'll type y1 equals ax1, and then shift, and you'll put the exponent as the, so you'll type shift 6 and then 2, but then you need to make sure you arrow out of that before typing plus bx1 and then plus c. That way, back here after the squared, if you don't right arrow out of that, you'll end up putting the plus bx and so forth next to the 2 instead of next to the whole thing. So anyway, I don't know why. Oh, not equals. Oops. Let's change the equals to that squiggly, and here we have our quadratic curve. Along with, we want that 400 though. We're probably going to, okay, anyway, along with your information, it gives you the A, B, and C, as well as your R squared value. So remember that your R squared values can help you determine which regression models more closely fit the data. So this one, the quadratic model, actually fits the data better than the linear model. Interestingly, right? But notice that to answer one of our questions where the population will be 400 million is, we can't see that up here. So what we need to do is you can use your mouse, the roller part on your mouse to zoom in. And you'll notice actually that according to this model, it doesn't reach 400 million. It comes up here. The vertex is somewhere right in here. There's 10. Oh, that's 60. That's right. It's already there. Right. 60, between 60 and 70 years. So probably right about 65 years after 1990. It reaches a peak at about 365 million. So it's not even going to get there, according to this model. That's all we need to say about that. For then we can either turn this off or leave it on. It's up to you. Then we type in number 4. which is going to be y1 again, and then this squiggly. This time we're doing exponential, so it will be A, B, and then shift 6, and put the x there, and put the 1 next to that x. And notice we have a different curve again. All right, so let's see here. Let's look at our R2 value, our squared value. This is not as closely modeled as the linear or the quadratic, but you can at least find your information. So here's where the population reaches 400. We can test for 10 years after, into the deal. Anyway, you can answer your questions using this model. Here again, we can turn this off. And then in box 5, we're going to do the same thing again. Y1 squiggly. Only this time we are going to put A plus B ln, and then parentheses. Actually, we don't need the parentheses. Sorry, x1. Now, we can hit enter or whatever, but notice it just gives us an orange triangle with an exclamation mark in it. That is because our data doesn't fit this type of model. So you're not going to be able to answer any questions about the situation for this model. And you can just state that the data doesn't fit. Anyway, then use what you've learned from all of them. You can even go back here and turn these all back on. Oops, scroll up. And notice where the curves all are and kind of see which ones more closely fit. Now, this plot, this E1 plot, if we do that, we can see the residuals. Which are down here, actually, along the x-axis. Now, the closer that these dots are to the x-axis gives us a really good indication of how close our data is modeled by that particular function. So if we close that off, and if we do the quadratic. Okay, so notice that the linear is in black, so we have black dots. The quadratic is in red, so we have red dots, and the red dots are really close, or even sometimes spot on, right? Then if we do the exponential plots here for 10 and 20, as well as 30 really, and 31, it's a bit off, farther than these others, which we can see by the R² value. So that is a good way for you to do those kinds of things since you don't have a graphing calculator. But I really would recommend that you get a graphing calculator because it will be so helpful and it's what everyone else is using. And I don't know if you'll be allowed to use Desmos on a test or something. So anyway, I hope that helped, and take care, and we'll see you next time. Bye-bye.